All right, so what do we have? We have a proof, which is quite an interesting thing. We have to prove that, tricky, that if alpha plus beta is 90 degrees, then sine alpha plus sine beta is greater than 1. Now we know that both sine alpha and sine beta alone is less than 1. So the statement is not trivial. There are two very famous inequalities, and I really want to teach you that other one. These two inequalities are all over the place when we have to prove inequality. Not solve, but establish that this is always true. And one of them is less than or equal to, and the other one is strictly less. And so whenever I look at the inequality type, that kind of tells me which way to go. It doesn't always work, but often enough for me to tell you. So when you have a strict inequality, think the triangle inequality. Also, whenever you take ratios, the best ratio that you can take is the one where the denominator is 1. So let's just start with this. So let's see how we can get to the triangle inequality here. Basically, we know that A plus B is bigger than C, right? How can we get 1 here? We would need to divide everything by C. That would be A plus B over C bigger than 1. We know that C is positive. You have to be careful when you're dividing or multiplying an inequality. Right? C is a distance. We don't have to flip the inequality sign. Furthermore, this is A over C plus B over C greater than 1. And if we look at it, A over C is sine alpha. And B over C is sine beta. And there we are. There is another way, which might be quite useful, and that is, why don't we just scale down to a triangle? The computation is going to be very similar, but the idea is, why don't we use a triangle similar to this, but with hypotenuse 1? That would mean that we would divide all 3 sides by C. So then this side is A over C, and this side is B over C. We can actually test whether these things are the trigonometric ratios as they are. In this right triangle, if we express sine alpha, we're going to get, well, sine alpha is A over C from here, but also from here, because we take A over C and we divide it by 1, right? But that means, and that always happens when you divide by 1, that this ratio becomes a length. This length here is sine alpha. And then sine alpha is A over C divided by 1 is A over C. And then A over C is sine alpha. And similarly, B over C is sine beta. And now we can just state the triangle inequality to this triangle, which would be A over C plus B over C is greater than 1, which is the same thing to say as sine alpha plus sine beta is greater than 1. So that's how that goes. So if we can create a triangle where one side is sine alpha, another side is sine beta, and the third side is 1, then the triangle inequality will state exactly what we want, which is this. This kind of scaling down to a hypotenuse 1 is going to be very important. So this is going somewhere. Thank you for watching.